Alright, so welcome back. In this video, I said we were going to look at the common line of reflection that was the parent function for the linear equation y equals x. When you graph that parent function for your linear equation, what you're going to end up with is the following graph. Okay? So if y equals the same value of x, right, if x is 1, y is 1. If x is 2, y is 2, because they're the same value, right? If x is 3, y is 3. So your parent function is, remember, just that diagonal positive slope with a 1 that goes through the origin. That is what our parent function looks like. Okay? So if we're looking to reflect a point off of that, here is what my rule is. The rule for the reflection across the line y equals x is your xy value is going to switch to y x. Okay, so that means you're going to take your coordinates and you're going to switch them. So let's say you have this point right here as your image, A, and it's the point 3, 1. You're just going to switch those 2 points. So instead of 3, 1, you're going to be 1, 3. 1, 1, 2, 3. A prime would be the point 1, 3. You just switch those x and y values. Okay? So let's look at an example. Reflect the triangles over the line y equals x. So again, the first thing I'm going to do is I'm going to graph that actual line. Okay? So I know I'm going to be going across these diagonals. Sometimes if I put those dots there, it's a little bit easier for me to sketch myself a line because I kind of have an eye placed for where my line is going, a direction for myself. Okay, and then I'm going to look at my 3 points. So my first point here is at -5, 2. My next point is -9, 3. And my last point up here is at -6, 6. And what we're going to do with each of those is just switch your x and your y. So this is going to become 2, -5. This is going to become 3, -9. This is going to become 6, -6. So let's graph those 3 points. 2, -5. 3, -9. And 6, -6. And kind of an interesting way that you can kind of check this is if you go with a slope of 1, or -1 in this case, to get from this point to its image, if I go across diagonally 1, 2, 3 and a half boxes, watch if I go a half box and then 1, 2, 3, I ended up right where I started. So those are the same distance from the line of reflection. Okay, so that'll work every single time. All right, let's do one more. When I look here at this one, okay, I'm going to do the same thing. The first thing I'm going to do is I'm going to graph my line of reflection. And again, for me, it's easier if I can make my little dots here. It just makes it easier for me to sketch that line. Gives my eyeball a place to head to. Okay? And then let's look at what our 3 points are. So I have -6, 3. I have -5, 8. And I have -2, 8. And all we have to do is switch the x and the y. So 3, -6, 8, -5, and 8, -2. And let's graph our new image points. 3, -6, 8, -5, and 8, -2. And again, if I want to check, I can pick a point and go diagonal across and see if it's the same distance from the line. 1, 2, 3, 4.5 boxes. So a half, 1, 2, 3, 4. So I can see that these are the same distance from the line, okay, for each one. All right, in the next video, we are going to continue with looking at reflections, and we're going to talk about not just the parent function y equals x, but we're going to talk about what if I switch that slope and have my downward facing slope and do y equals negative x. So come on back for that next video. Thank you so much for watching.